let's look at question 3. Question 3, it's actually a two-part question. It involves a measurement, which is what you are currently looking at. There's also another part of the question where it talks about analytical geometry. Okay, so there's two topics under question 3. All right, in the description box I'm gonna leave links for other questions that I've answered for this question paper. Okay, so let me hide this one. And this question has a last question 3.2.5, but we're gonna get to it. But let's start with the 3.1, right? So here we are given a toy that is made by joining a hemisphere. All right, let me underline this word. This is a key phrase in this discussion. A hemisphere. Where am I writing? Oh, I should go up. Okay, so we have a hemisphere. Let me use something a bit bright. We have a hemisphere of radius 10 centimeters and a cone of radius 10 centimeters again, right? And a perpendicular height of 15 meters. So umabati a perpendicular height, it's actually a height from the center of the circle going all the way up to the vertex of the cone. So the vertex, it's that pointy part of the cone. Okay, that measures what? 15 centimeters. All right, so both the cone and the hemisphere have a equal radius, which is 10 centimeters. Okay, now I've underlined the word hemisphere as well as the word cone because this shape, jongoba uibona, it's actually composed of two different shapes. We have a cone and a hemisphere. All right. Now with 3.1.1, they want us to calculate the volume of the toy. Now, I'm gonna bet you this. There is no formula that can calculate a volume for the whole shape. None. There isn't one. There's a reason why they are saying to us, we have a hemisphere, we also have what? A cone. Like there's no formula, like one unified formula for finding a volume for that whole shape. What you will have to do is actually to calculate the volume in parts, meaning that we'll have to calculate the volume for a hemisphere first and calculate the volume for the cone, and then we combine the two. Okay, because this shape is it's sort of like an ice cream cone shape kind of thing, right? Kind of shape. There is no one formula, unified formula for calculating this. Instead, we have to calculate it in parts. Calculate for the hemisphere, calculate for the cone, then we combine the two. All right, that's the reason why they are telling us this one is a hemisphere, this one is a cone. Combined, they give us the full shape, which is a toy, by the way. So 3.1.1, calculate the volume of the not the cone but the toy. It's gonna be 3.1.1. Volume of the toy is equal to the volume of the hemisphere plus the volume of cone. Okay, volume of cone. So let's do this. We're gonna do this. We're gonna consult our formula sheet. The formula sheet. So on the formula sheet, these are gonna be the useful formulas for our discussion. Okay, these are the useful formulas for a discussion yet. Now, I want a formula that will help me to calculate a volume for a hemisphere. A hemisphere is basically a half sphere. I'm also looking for a formula for calculating a volume for a cone. Now let's consult our formula sheet. I can see that with formula number 13, there's a formula for finding a volume of a cone, which is this. Now I know how to calculate the volume for what? For the cone. I'm going to use that formula. I have the radius. I have the perpendicular height. All right, I have everything I need. Okay, I have everything I need. Next one would be getting a formula for calculating the volume for a hemisphere. Let's see. It's definitely gonna be formula number 15. But caution, take caution. Formula number 15, it calculates the volume of a sphere, of a full sphere, of a full ball, right? But what do we have? We have a hemisphere. We want to find the volume for a hemisphere. So we're going to take this formula and basically multiply it by a half or divide it by a 2. Then we're going to get a volume for a hemisphere. So we're going to do this. I now have also the formula for finding the volume for a hemisphere. So it's going to be, I'm going to take that formula for finding a hemisphere, which is, for finding a volume for a sphere, it's 4/3 multiplied by pi r cubed plus the volume for a cone, it's 1/3 pi r squared multiplied by the perpendicular height. But now for the hemisphere, we're gonna have to take the volume for a complete sphere and multiply it by a half. You can write it like this or just divide by 2 like this, but I think it's gonna be much more organized if we say multiply by a half. All right, so what's the reason for multiplying by a half la? Just for re-emphasis, the volume, the formula we have, formula number 15, it's a formula that calculates the volume for a full sphere. Tina, we are dealing with a hemisphere. A hemisphere, it's half of a sphere. All right, now continuing with this calculation, we're now just gonna do a substitution. So it's half 4/3 multiplied by, what is pi? You know what, pi, I'm just gonna substitute pi as is. So I'm just gonna punch, I'm just gonna punch pi on the calculator as is. Pi multiplied by, what is the radius? The radius of the hemisphere, we are told it's 10 centimeters. So I'm gonna substitute 10 cubed plus 1/3 multiplied by pi. What is the radius? It's also 10 for the cone, squared multiplied. What is the perpendicular height? This symbol, this upside down T, simply means perpendicular. The H stands for height, right? What is the perpendicular height? We are given as 15 equal to. Now let's calculate. Let us calculate. Okay, so it's gonna be half multiplied by 4/3 multiplied by shift now pi lapha multiplied by a 10 raised to exponent 3 plus 1/3 multiplied by pi multiplied by a 10 squared multiplied by 15. So this is my final answer. I'm gonna round it off to 3 decimal places. It's 3665,191. So that's the answer. Let me hide the calculator again now. Oh, my units, it's gonna be centimeter cubed. So you see what we did now. We actually don't have a formula on our formula sheet that allows us to calculate the volume for this entire shape. So what is the approach now? Is actually to calculate the volume in parts by saying hemisphere volume, cone volume, were calculated separately, then you add them up at the end. Okay, now for the next question, 3.1.2. so I'm gonna hide this. I'm gonna hide this. 3.1.2. Again, we're gonna consult our formula sheet, right? So which formula are we going to use now? It's gonna be formula number 12. slant height of a cone. Calculate the slant height of the cone. So if you check your formula sheet, you can see that there's actually a formula for finding a slant height, which is this. All right, which is this. Now, what is the slant height? There's two types of height. There's this height, which is referred to as the perpendicular height, right? Which is that 15. The slant height, let me highlight that by green. This is the slant height. This is the slant height. Okay, this is the slant height. So this is gonna be also gonna be equal to that. All right. So 3.1.2. Okay, this one is a straightforward one. So the slant height, which is represented by L, is equal to the square root of h squared plus r squared. H is the height. Now, which height? It's actually the perpendicular height. What about r? R is the radius. Okay, is the radius. Slant height is equal to the square root of, what is the height? That's 15 squared plus, what is the radius? That's 10 squared, equal to, so consulting a calculator yami. Okay, let me see, when 15 squared plus 10 squared is equal to 5 square root 3, 5 square root 1 3, not 3 but square root 1 3, 13. Let me hide the calculator. So slant height is equal to, let's bring back the calculator, see the SD. So in 3 decimal places, that's gonna be 1807, okay, 278, 028, not 78, 028, yeah, centimeters. This is our answer again. Okay, that's 3.1.2. 3.1.3. 3.1.3. Let me check something. Is the calculator gone? Yes. All right, 3.1.3, they want us to calculate the total surface area of the toy. The toy. Let's create another slide. 3.1.3. Calculate the total surface area. Let's call this TSA, the total surface area. Now, okay. On the formula sheet, there's always going to be a formula for you to use. In every question that they give you, more especially involving a measurement, if they want you to calculate the volume of something, if you go to your formula sheet, there's always going to be a formula that you can use to work out your problem. As long as you understand the statement and you know what kind of shapes you are given, right? And you know what a slant height and the perpendicular height is, all right? So we have a cone. We are told in that statement, we have a cone. We also have a hemisphere. But the hemisphere is not a full or a complete sphere. It is it's half of a sphere. Now, let's consult our formula sheet and see how do we actually calculate the area or the total surface area of any of the shapes that we are given. So formula number 11, we have the area of curved surface of a cone. Okay, so area of the curved surface of a cone, it's actually this. It's gonna be this. So we're gonna be using this formula, right? This formula, it says what? It says pi r L. Now remember, the L represents what? Slant height. It represents slant height, and then the R is of course the radius, right? So remember now, I have a hemisphere. I have a cone as well. I also have what? A cone. So this pi RL, it calculates the surface area for the cone part. Now we'll have to calculate the area for the hemisphere. How do we do that? Which formula can we apply? It's gonna be formula number 11. Okay, there's two 11s, but anyway, that's fine. It's this 11. So everything that I have here is actually listed out in the formula sheet. So number 11, area of the curved surface of a cone. Wait, it's actually the same formula. Oh, okay, what's the deal? Oh, okay, it's actually formula number 14. Area of a sphere. Area of a sphere. Area for a sphere, right? So now this area calculates this formula calculates the area for a full or complete sphere. Tina, what do we have? We have a hemisphere. So we're gonna say when a 4 pi r squared, we're gonna multiply you by a half. We're gonna say multiply by a half. Or you can divide it by a 2 because we have a hemisphere, right? Not a complete sphere. Now let us substitute and work out the answer. So it's gonna be pi multiplied by, what is the radius? That's 10. What is the slant height? We did calculate the slant height. It's what now? It's 18.028. Just a quick pick. Okay, I'm now getting lost. Is it this? Yeah, it is. Where was I writing? Okay, plus half of 4 times, what is pi? We're gonna use pi as is, multiplied by the radius squared. So the radius is 10. We square this, equal to, let's work out the answer again. Okay, so this is gonna be pi, so it's shift pi multiplied by 10 multiplied by 18.028 or square. Okay, nothing of that sort. So it's gonna be a plus half multiplied by, I understand that the calculator is hiding the calculation, but just bear with me for a moment, and then the answer that we get is this. I'm missing a pi, equal to, so the answer is gonna be 1194, comma, I have to bring it back, 685 centimeter squared. Let me remove the calculator here. So this is the total surface area. So you guys, I don't actually understand what seems to be the problem around the topic of measurement, because all of the formulas are provided. When you just have to identify the shapes and know what to actually calculate. But just make sure you read all the statements that you are given, or all the information that you are provided with. Okay, now let's go to the second part of the question, analytical geometry. Let me just clean up the board. Okay, let's bring up this question again. So we are on analytical geometry again now. 3.2, in the diagram below, ABCD is a quadrilateral where the coordinates A, B, C are given. All right, D is not given. The diagonal BD intersects the x-axis at the origin, right here. Okay, I need red, man, not white. Right here. This is the origin. So the coordinates, we know that they are 0 and 0 at the origin. Okay. Yeah, at the origin. So this is the shape. It's a quadrilateral. We don't know what this quad is. Right? We actually don't know what this quad is. It could be a parallelogram. It could be a square. It could be a rectangle. We don't know. We can't assume or say anything about it, but we do know it's a four-sided shape. All right. Then with 3.2.1, determine the equation of line BD. Where's BD? Right here. This is BD. All right, how do we calculate the equation for a straight line? In the description box, I'll also leave my links or the playlist that I've created for analytical geometry. I think you're gonna find it useful, right? I'm gonna leave it in the description box, but now I'm just gonna go straight to the calculation. But I'm gonna take you step by step. Now with 3.2.1, we want the equation of a straight line BD. An equation for a straight line we calculate by y equal to mx plus c, or you can use this formula y1 mx minus x1, like either of the two formulas you can use. All right, but the first thing you're gonna need, it's the gradient. You're gonna have to calculate the gradient. After finding the gradient, you're gonna need 1 point to work out the equation. So you need two things. One, you need gradient. Two, you need a point. Okay, you need a gradient to substitute m. You need a point to work out the full equation. All right, so how do we calculate the gradient for BD? I have 2 points. It's the origin as well as B. I can use point B, no origin, to calculate the gradient. So we're gonna do this. Y, the gradient is equal to y2 minus y1 over x2 minus x1. Okay, minus x1. So this is going to be equal to, what is y2? That's 3, minus what is y1? That's 0, over what is x2? It's minus 1, minus 0. All right, so I'm taking point number 2 to be B, and then I'm taking point number 1 to be the origin. So hence the substitution. So the gradient now becomes what? 3. Now the gradient becomes what? 3. Okay. I like using this formula to work out the equation. Of course, you can use that one. It's still fine. But let's use this one for our discussion. So the equation for BD, it's y minus y1 equal to mx minus x1. All right. So where there's y, I'm going to substitute. Where is y1? Like no y1 or x1, I'm going to substitute a point. I can either substitute origin or b. It's up to you. Let's substitute b. I know the easiest one, or the easiest way or path for this calculation would be actually to use no origin. But for this discussion, let us use b. So y1 is going to be 3. Gradient, it's 3. X minus, what is x1? It's minus 1. Y minus 3 is equal to 3. X, negative times negative, that's a plus. Y minus 3 is equal to 3x plus 3. We transpose, wait a minute. So this thing yung nigeza phela. All right, that's negative 1 sharp. Whoa, okay, no, the gradient is negative. My apologies. If you punch this in your calculator, you should get a negative 3. Yeah, now it makes sense, because when I get to the step, I can see that if in transpose the 3, I'm gonna get a plus 3. So it's gonna be 3 plus 3, then in total 6, meaning that I have a y-intercept of 6. So yeah, I had to be extra careful. So lana it's negative 3, multiplying by the negative 3, so total minus 3x, and okay, it's 3 and a minus 3. All right. Now let's transpose this 3 over minus 3x minus 3 plus 3. This plus 3 is this one when transposed. So adding gives us a minus 3x. So this is the equation for BD. I'm not sure if we're going to need this information for the next calculation. BD, BC. No, I don't think so. Okay, so we can actually erase this. Now let's answer 3.2.2. Calculate the angle of inclination of BC. Calculate the angle of inclination of BC. So BC, it's this line. It's this line here. We want the angle of inclination theta. So how do we work this one out again? Angle of inclination is calculated like this. It's theta equal to arctan of the gradient for that line. So in our case, it's line BC. So we actually need what? The gradient for line BC. We need the gradient for line BC. So first, we're going to calculate a gradient for line BC. So it's going to be YB, YC over XB minus XC. Or you can say Y2 minus Y1, X2 minus X1. That's still fine. All right. YB, that's 3, minus what is YC? It's -1. We put it in brackets. XB, that's -1, minus what is XC? That's 3, equal to, so lights 4. Yeah, I don't want to make the mistake we did on the previous calculation. So it's -4 minus 1. Yeah, so it is a negative gradient. All right, it is a negative gradient. Now I want you to take note of something, that the angle of inclination here, it's actually an obtuse angle. It's an obtuse angle. So meaning that it's bigger than 90 degrees, all right, but less than 180. All right. So to work out the angle of inclination of a line with a negative gradient, we always add to 180 degrees. Now the theta, it's going to be equal to 180 plus arctan of the gradient BC. But when we substitute, we remove the negative sign. No, not plus but minus. My apologies, not plus but minus. So it's gonna be 180 minus arctan. What is the line BC? The gradient of line BC, that's 1. Theta now becomes 180 minus arctan of 1, that's 45 degrees. That's 45 degrees. And then taking the difference between the two, so total 135 degrees. So this is our answer. Okay, this is our angle of inclination. Determine the equation of line CD, given that it is parallel to AB. CD. All right, so let's hide this. Let's hide this. Yeah, with 3.2.3. All right, so in order to calculate an equation for any line, you need a point and a gradient. Okay, a point and a gradient. Now we want the equation for line CD. The problem is I only have one coordinate. A coordinate got D I don't have, so I cannot calculate the gradient for line CD directly. But what I can do, I can work out a gradient for line AB. After finding the gradient for line AB, it's equal to this one. So in other words, by finding the gradient for this line, I'm gonna have the gradient for this line as well. Why? Because they are parallel. They are parallel lines. Parallel lines have equal gradients. Okay, so gradient for AB is equal to gradient for CD. How do I know? It's because of line AB is parallel to line CD. So we can actually start off by calculating the gradient for AB. So that's gonna be YB, YA, XB, XA. What is YB? That's 3. Minus what is YA? That's 1. Over what is XB? That's -1. What is XA? That's -3. 3 minus 1, that's 2. Lana, it's going to be a minus plus 3 That's 2, 2 equal to 1. Alright, so the gradient for line CD, it's also going to be equal to 1. Alright, therefore we're going to use this formula, x minus x1. Alright, so it's going to be y minus, what is y1 and x1? It's the point on line CD. Remember, we want the equation for line CD. We want CD. Now for line CD, let me go back. For line CD, in order to get the equation for line CD, you need the gradient for line CD. We just calculated that. I also need a point along the line CD. I have its point by C. So where there's y1 and x1, that's where I'm going to substitute the point C. So what is y1 or negative 1? What is m? The gradient, it's 1. X, what is x1? That's 3. Y plus 1 is equal to 1 x minus 3. So multiplying by the 1 inside the bracket, this is what we get, 1x minus 3. Now let's transpose 1. It's gonna be 1x minus 3 minus 1. Now 1 is equal to 1x minus 4. This is our equation. Alright, next question, 3.2.4. Determine the equation of line AD given that it is perpendicular to AB. AD. Oh, okay. Alright, let's hide this. See, with 3.2.4, I'm gonna highlight the line that they want us to calculate the equation for. So the red line, they want us to calculate the equation for this line. The green one, it is perpendicular to the red one. So these lines, this time they are perpendicular to each other. We know that perpendicular line AB, when you multiply their gradients, you should get a minus 1. So gradient for line AB, when multiplied by the gradient for line AD, we should get a minus 1. Alright, a minus 1. But we did calculate the gradient for AB. So it's 1. Now going back here and substituting gradient AB as 1, AD minus 1. Okay, then dividing by the 1 both sides, we can see that gradient AD is equal to minus 1. I need the gradient for the line AD. I'm looking for the equation for line bunny AD. So I need the gradient and at least 1 point along that line in order to get the equation, because when we calculate or find the equation, it's y minus y1 m x minus x1, right? So it's gonna be y, where there's y1, I'm substituting. Okay, so along the red line, I have point A as a coordinate. So let us substitute to A lapa. So y, it's 1. Y, that is 1. M, it's minus 1. X, what is x1? Negative 3. So it's going to be a negative 3. It's minus negative 3, close bracket. So go about y minus 1 x plus 3, then go about minus 1, multiplying by the negative 1 inside the bracket. So it's minus x minus 3. Transpose the minus 1. About minus x minus 3 plus 1. Y is equal to a minus 3 minus x minus 2. Now this is our equation for the line AD. Alright, now for the last question, given that the equation of the line BC is y equal to minus x plus 2. Alright, I'm not going to erase this part this time because I think it's relevant this time. Yeah, it's relevant. Okay, so 3.2.5, we are given the equation y equal to minus x plus 2. It's for line what? BC. This equation is for line BC. And then write down the coordinates of E. Let me put a color blue for E, and the F coordinate. The F coordinate, which are the y-intercepts of line BC and AD. Now, this equation represents a line BC. This other equation, the one we were just calculating just now, okay, I don't have to rewrite this one. This equation represents the line, the equation for line bani AD. Now, from the sketch, we can see that F is the y-intercept for bani for line AD. This red line, right? And what is the coordinates for F. And then we are also presented with another equation, BC. They want us to write the coordinates for E, which is the y-intercept for BC. Now, this, I get the line of a straight line, it's normally expressed as y equal to mx plus bani plus c. This c value represents the y-intercept. It represents the y-intercept. So in this case, this 2 is actually the y-intercept for line BC, meaning that it's gonna be or represent the coordinates for E. So it's gonna be 0 and 2. And then for this, it's gonna give us the coordinates for F. It's gonna be 0 and minus bani 2. But the question doesn't end here. It also says calculate the distance between, determine the distance between E and F. Now the distance is the length from E all the way up to bani to F. Now we just worked out the coordinates for La, and we saw that it's 0 and minus 2. Lana is 0 and 2. Okay, so the distance from the origin to here, that's 2 units. How do I know? And then the distance from here to here, it's also 2 units. Now distance between UE F, it's actually 2 plus 2 units is equal to 4 units in total. All right, so just keep in mind when calculating a distance, or check. Instead of calculating a distance like this, you can actually use the distance formula and work out the distance between these 2 points. That's it. But just to explain how I did the calculation is that whenever we calculate the distance, you need to use positive values. Hence, I changed this -2 into a positive unit because calculations wayenza with positive values, right? The distance is always positive anyway. All right, so this concludes our discussion on measurement analytical geometry. I hope you enjoyed. If you did, leave a like. You have a question, let's talk in the comment section. For now, I'm signing out. On the next one. Peace.